What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A plus 1201 certification exam. So let's get into it. If you ever cracked open a computer case, then you've likely seen a giant flat piece of tech filled with all kinds of ports, slots, and chips. Well, that is the motherboard, which is the heart of your system. It's where everything connects and communicates. But how do you pick the right one? What about the CPU? And what's up with all those add-on cards? Well, I'm going to break all of that down for you. This video isn't just grounded in theory, it's grounded in the real stuff that you need to know for the CompTIA A plus 1201 exam. So with that being said, let's go. All right, so before you pick a motherboard, you've got to understand the size and shape, or what we call the form factor. And here are the three major ones. The first one is called ATX, and that stands for Advanced Technology Extended. And this is the standard size for a motherboard. It measures around 12 by 9.6 inches. It offers the most expansion slots, RAM slots, and other features. And this is great for gamers, power users, or anyone building a full tower system. You have what is called micro ATX, and this is smaller than the ATX, around 9.6 by 9.6 inches. It has fewer expansion slots, but it's often cheaper, and it's still a good choice for most users unless you need maximum customization. And then you have what is called ITX, or Information Technology Extended, and this is super compact. With the mini ITX is just about 6.7 by 6.7 inches, and it's limited to one expansion slot, and this is ideal for small form factor PCs like HTPCs or space-saving office builds. Now, as a tip, you always want to match the form factor to your case. A micro ATX, this will fit in an ATX case, but not the other way around. All right, so once you have picked out a motherboard, then you need to understand its connectors. And these are where everything from your hard drives to your graphic cards plug in. And the first type of connector is called PCI, or Peripheral Component Interconnect. That's these things right here circled in red. And this is an older standard, and it's rare in modern systems, but it still shows up in legacy equipment. You got PCIe, or PCI Express, and this is the current king of add-on slots. And this comes in different sizes like by 1, by 4, by 8, and by 16. That's exactly how you pronounce it. It's by 1, not X1 or anything like that. And this is where you will plug in graphics cards, NVMe's, SSDs, network cards, and a whole bunch of other stuff. Next, we have our power connectors, and this is your 24-pin ATX main power connector. You also have 4 and 8-pin CPU power connectors, and some boards, they also use additional PCIe power connectors for some GPUs. You got your SATA, or your serial ATA connectors, and these are for connecting traditional hard drives and SSDs. And these are oftentimes slim, fat cables that are easy to route. You got your eSATA cables, and these are an external version of the SATA cable. Now, these are rare these days because they have been replaced by USB 3.0 and USB-C for most external hard drives. And these blue connectors on the motherboard, this is where your SATA connectors will plug into. You also have what are called header pins, and these are tiny pins that are used to connect front panel buttons like your power button, your reset button, audio jacks, USB ports, and a whole bunch of other stuff. Now, it is easy to miss, but these are super important for your case functionality. And then you have your M.2 slots, and right here on your screen, this is where you would stick your M.2 SSD up in there. And this is a super fast connector for SSDs and sometimes Wi-Fi and Bluetooth cards. And it does somewhat look like a gum stick, and you can use SATA or NVMe protocol, so make sure your board supports the right one. All right, so let's talk about motherboard compatibility. So let's say that you buy a shiny new CPU, but it will not fit on your motherboard. Well, exactly what happened? Well, you probably got the wrong socket type. So there are two main CPU manufacturers, and they each use different sockets. First one is called Intel, and that's this picture right here. This is a popular socket. You got LGA 1200, LGA 1700, and the LGA that stands for Land Grid Array. And basically, these are the pins that are actually on the motherboard. They are known for performance in gaming and single-threaded tasks. Then you got AMD right here, and the popular sockets for them are known as AM4 and AM5. Basically, the pins are on the actual CPU, so be careful when you install these things because you do not want to bend these pins. You mess around and bend these pins, then your computer is not going to work at all. But anyways, these are also called PGA sockets, and that stands for Pin Grid Array, and they are mostly known for multitasking and core heavy workloads. You also have multi-socket motherboards. Now, these are rare outside of servers or workstations. And these boards, they allow for more than one CPU. And this is not something that you're going to deal with often unless you're building a beastly server setup. Now, as a compatibility tip, you always want to check the motherboard CPU support list before you buy anything because not every AM4 board will support every AM4 CPU. All right, so let's move on and talk about the BIOS versus UEFI. So when you boot your PC up and you hit the delete button or the F2 key, you're going to enter the BIOS or the UEFI. And this is your firmware setup screen. So this is your BIOS right here, and this is your UEFI right here. So exactly what is the difference? Well, BIOS is older and it's limited to 16-bit mode with a basic interface. UEFI, this is the modern replacement. It supports larger drives. It has a GUI or a graphical user interface and offers better security. So essentially, they do the exact same thing, except this is just a newer version. That's all it is. And here are some things that you should know when you set these things up. So within the BIOS UEFI, you're going to have boot options, and this is going to decide which device starts first. When you turn the computer on, whether it's going to pull from the USB, the SSD, or the DVD, because basically when you turn your computer on and it boots, it's essentially looking for where is the operating system installed. So if you have your operating system installed on the hard drive, but you have your boot option set to USB, you're going to get an error saying that your computer does not have an operating system because your computer would essentially be looking for your operating system to be on the USB, even though you have it installed on the actual hard drive. But being that you didn't change your boot order to go to the hard drive first, it's going to the USB and it's going to produce that error. And then you also have USB permissions where you can enable and disable USB ports. And this is a security feature to prevent unauthorized data access. You have what is called TPM or Trusted Platform Module. And this is used for hardware encryption, like setting up BitLocker. And this is required for Windows 11. You can go into the BIOS UEFI and control your fan speeds, or you can adjust the speed profiles to manage noise and temperature. You can set up secure boot, where it ensures only signed operating system bootloaders are allowed. And this helps protect against rootkits and boot time malware. You can set up boot and BIOS passwords to prevent unauthorized changes to the access system. And you can check on the temperature, like check the CPU and system temperatures to prevent overheating. Now, as a tip, if you ever mess up the BIOS settings, there's usually a low defaults option up in there somewhere, or you can just simply pull the CMOS battery out to reset everything. And the CMOS battery is just a little circular battery that sits on your motherboard. You just simply pull that thing out, wait a couple seconds, put it back in, and in theory, everything should work fine. All right, next, let's quickly talk about virtualization support. So if you ever wanted to run Windows inside of Windows, then that's what virtualization does. It's basically setting up a computer inside of a computer. And most modern CPUs, they do support hardware virtualization, where you got Intel, VTX, and AMD V. And you can turn this thing on and off in the BIOS or UEFI, and this is used for setting up things like VirtualBox, Hyper-V, or running test environments. Next, let's talk about encryption. So we touched on TPM earlier, but let's talk about it a little bit more. So once again, TPM, this stands for Trusted Platform Module. And basically, this is a hardware chip that is built onto the motherboard where it stores keys, passwords, and other certificates securely. Then you have what is called HSM, or a hardware security module, which is what you're looking at on your screen right here. And this is an enterprise level hardware that is used for high security environments like banks and governments. This is rare in consumer PCs, but it's still good to know for the exam. And this thing just basically stores a bunch of security keys as well, because encryption, this ensures that your data stays safe even if the drive is stolen. So you always want to have some encryption turned on. All right, next, let's talk about the CPU architecture, or the brains of the operation. So your CPU is more than just a speed number. It has an architecture that dictates how it works. And we got two types. We got x86 and x64. And x86, this is a 32-bit architecture. It's older and less RAM is supported with it. Then you have x64, and this is used for 64-bit systems. And it also supports more RAM and it offers better performance. But you also have what is called ARM, or Advanced RISC Machine. And the RISC, that stands for Reduced Instruction Set Computing, which is great for power efficiency. But this is what you're going to find in your smartphones and tablets when it comes to the CPU. So think of your Apple M1 and M2 chips and the chip that's sitting inside of a Microsoft Surface. You also have some core configurations when it comes to CPU architectures. So CPUs, they could be single core, which is ancient history. You got dual core, which allows for them to do basic multitasking. You got quad core, hexacore, octa-core, which is all standard today. You got something called mini core, and that's used for workstation servers or some serious gaming computers. And essentially, the more cores you have, then the better multitasking and performance your computer can do at the end of the day. All right, so let's move on and talk about expansion cards. So sometimes what your motherboard gives you is not enough, and that's where expansion cards come in. So here are the main types that you need to know about. First one is called a sound card, and this gives you advanced audio processing, and this is useful for music production or high-end speaker setups. You got your video card down here, and this is required if you want to get into some serious gaming, video editing, 3D modeling, or doing some stuff with AI. And this graphics card in particular, if you look at the pins down here, this is going to install into a PCIe by 16 slot. And also this thing has its own cooling and its own memory. Next, you have what is called a capture card, and this thing can record video input from cameras, consoles, or another PC, and this is extremely popular for those who like to stream. You got what is called a network interface card, or a NIC, and that's where you plug your Ethernet cable into your computer so you can get some internet access. And then there's also the Wi-Fi version as well if you prefer Wi-Fi. Now, as an installation tip, you always want to power down your PC and ground yourself before inserting expansion cards into your system. And do not forget to install any drivers afterwards if you want these devices to work properly. All right, next let's talk about some cooling, because your CPU can get hot. I'm talking about really hot. And if you don't cool things down properly with your computer, then things are going to start throttling and eventually shut down. So here's how you can handle the heat. You got fans up in there, and they provide basic air cooling. You got case fans that can bring cool air in and push hot air out. You also got CPU fans, which you're looking at on your screen right here, where they sit directly on top of the processor. So directly up under this right here is the processor. Then you have what's called a heat sink. That is actually this aluminum thing you're looking at right here that's sitting directly on top of the processor. And this is a chunk of metal, usually aluminum or copper, that absorbs the heat from the CPU. And this works in tandem with the fan. And then you got what is called thermal paste or thermal pads. And this is basically a substance that fills any microscopic gaps between the CPU and the heat sink. And this is vital for efficient heat transfer, because if you put too much of it on or too little, then you're going to have some problems. Then you also have liquid cooling. And this circulates some type of coolant liquid through a pump, tubes, and a radiator. And this is more efficient and quieter than air cooling. And another thing, when it comes to most users, this system setup is overkill, but it is a must-have if you are out there overclocking anything on your system, or you just want some cool looking computer build. All right, so let me go ahead and give you some tips for installing and configuring this stuff. So before you install anything, you want to RTFM, read the freaking manual, because every motherboard is different. Static electricity is your enemy. So use an anti-static wrist strap, or touch a piece of metal that's touching the ground before you handle any components to discharge your body of static electricity. Then also test the outside case first if you're building a new system. Now, during the installation, you do not want to force anything into its place. If a component does not fit, then double check the orientation and compatibility. You also want to use what are called standoffs to avoid shorting the board to the case. And you want to route your cables neatly to maximize airflow and aesthetics. Then after you install everything, you want to enter the BIOS and check your temperatures. You want to make sure all your components are detected, like your RAM, your CPU, and your drives. You want to install your operating system and update your drivers right away. Now, exactly why does any of this stuff even matter? Well, understanding how to install and configure motherboards, CPUs, and add-on cards, this is one of the most hands-on, job-ready skills that you will gain on your CompTIA A+ journey. Whether you're building your first PC, troubleshooting a client's machine, or just upgrading for performance, these skills give you power, literally and professionally. So the next time you see a mess of ports, wires, and circuit boards, don't panic, because you have watched this video and now you are a subject matter expert on how to deal with all of that stuff. Now, with that being said, let's do some check on learning. So our first question is, so which of the following CPU socket types uses the pin grid array processors? Is it the LGA 1200, the AM4, the LGA 1700, or socket 478? And the correct answer is AM4. So AMD processors, they typically use the AM4 or the more recent version, which is known as AM5 socket type. Now, unlike Intel's LGA sockets, which stands for land grid array, AMD's AM4, they use the pin grid array design where the pins are on the CPU itself. And LGA 1200 and LGA 1700, these are used by Intel CPUs. And if you're wondering what does the 1200 and the 1700 stand for, basically those are the amount of pins on the LGA socket. That's all that means. Next question. Which motherboard connector type is primarily used for connecting high-speed solid-state drives in a compact gum stick form factor? Is it PCI, SATA, M.2, or eSATA? And the correct answer is this is M.2. So M.2 slots are used for modern SSDs and sometimes Wi-Fi cards. They support high-speed storage devices using either SATA or NVMe protocols. They're small, fast, and efficient, and a major upgrade from your traditional SATA drives. And our final question is, you just installed a new graphics card in a PCIe by 16 slot, but your system doesn't recognize it. What's one of the first things that you should check? Should you check if the CPU supports a secure boot? Should you check if the fan is spinning on the power supply? Should you check if the graphics card has been overclocked? Or should you check if the necessary power connectors are plugged into the GPU? All right, so one of the first things that you're going to want to check is to see if your power connectors are plugged into the GPU or the graphics processing unit, i.e. your graphics card. So modern graphics cards, they often require their own dedicated power from the PSU or the power supply unit via a 6-pin, 8-pin, or even a 12-pin connector. And even if everything is seated properly in the PCIe by 16 slot, it will not function without enough power. So always double check those connections.